Hello everyone. Today we'll be learning a very important concept in system programming, something called as shared libraries. If you have ever used standard functions like printf, scanf, and so on, you have used actually a shared library, even if you never realized this. Shared libraries allow us to write reusable code and link it dynamically to programs at runtime instead of statically at compile time. Now, what this means actually, we are getting better memory efficiency, reduced executable size, and easier updates. Let us see this process step by step, how to create a shared library. So let me first uh, tell you what exactly the shared library is. Shared library is a file with a .so extension on Ubuntu or Unix kind of systems, which stands for shared object. This file contains compiled functions that can be dynamically linked to a program at runtime. Now, there can be multiple benefits while you use this shared library, like multiple programs are permitted to make use of same library code in memory. We can update the library without recompiling the dependent programs again and again. And since the code is not embedded directly, ultimately the executable size is smaller. So when we compare static library and dynamic library together, static libraries are embedded into the final executable and that way increase the size. But with dynamic library, it doesn't affect the size of executable. So let us try to create a shared library from scratch. Let us first create a folder. So let me create one folder like my shared library. Just to introduce you like how exactly we do this. Okay, now further, we will create simple C file which contains some functions. Say we will add two functions there. So let us say Emacs my functions dot c. Now we will write these functions where like one of them would be like one or two of them would be working with arithmetic operations, and there we will add some kind of prints even like for printing some messages. So let us include stdout.h. We'll add now a function integer add int a int b and simply we'll return a plus b. Similarly, what we'll do is we'll add more functions. I will write here sub minus. Let us add another one more function called say print mhg. Okay. Now whenever we call this, we will print say for example like this printf hello. You are executing a shared library function. Fine. Okay. So now let us say we have these files readily available. So instead of void, we'll write instead of int, we'll write void because we don't want to return anything here. Now we have added three functions here. There is add, which returns sum of two integers. There is subtract, which sub function, which returns subtraction of two numbers. And we have added one print message function, print underscore msg, which is a simple function that prints this message. What is the message that we added there? Now, what we'll do is we'll create a header file. Okay, let us create this. It is optional though, but it is good to rather to make use of this type kind of thing. So you can declare rather this kind of header files. Okay, now I'm telling you as an expert what exactly you should do. Okay, so you have created the C code rather containing three functions. Now we'll create a header file so that other programs can include this library properly. So let us create, say, for example, Emacs myfunctions.h. Okay, and what we will do is here is we'll because this is our file myfunctions.h. So I will add, so if and if I will let you know why we are adding this my function underscore h hash define this, correct. Then we will write the names of the function that we have added. So let us see the functions. So these are the names of the functions. So we'll try to input those names here, okay, as an function template. Sorry, I will take it here so that I can see the names. Okay, so we have added functions there. So let us say print msg. This is a prototype, say we are adding in if and def void. Then there is a function int add int comma int. We'll make modifications if required later. And then we have int sub int comma int. Fine. And simply add int if. Now here, what we did here, we have added header guards, if and def and hash define. Prevent They can prevent the multiple inclusions. And it declares the functions available in the library. Okay. So let us compile, say, the code that we wrote earlier. I will keep this file as it is. Okay. Now, what is to be done is to create a shared library, we need to make our object file for the .c code with respect to the position independent code. I'll be discussing what exactly the position independent code is. So let us create the position independent code. So let me see. Okay, so let us write GCC because we want to create this function. Okay, as an what you can call it as the library function. Fine, and we want these functions to be part of our file. So less my functions.c. Now, if you see, we have three functions added there. Correct. Now, when we added these three functions, ultimately, what we have to do is the next thing that we are going to do is like we are going to create a position independent code -c with our function name, the program name .c. So we'll create it as a 32-bit thing. So that's why -m32. Fine. Now, what exactly this position independent code is? So let us check. So if I write say file my functions.o. Now what we are seeing here, it is a 32-bit LSB, okay, relocatable file. So we created this as a position independent code. Now, if we have to talk about PIC, that is position independent code. So this is like the name itself tells, like the long form itself tells us that it is going to be position independent. But when we say that this is a position independent code, what exactly it means is it is a machine code that can execute properly regardless of its absolute memory address. And this is crucial when the code is loaded into different memory locations at runtime. And it is common for shared libraries on Linux or probably dynamic link libraries on Windows. Correct. So like when multiple processes use the same shared library, PIC allows us or allows the OS to load just one copy of it into memory and map it to each process address space. That is one advantage. And without PIC, like without position independent code, each process would need a separate copy at fixed memory location. And that's the reason why we created this as a position independent code. Fine. So let us go further. Now we have to create the shared library. Now what exactly we do? So like the one we created now is .o. We will be using this .o with for creating a shared library. So right here dash shared. Okay. Then you write your so file name. So I will write it as lib my functions .so. Okay. And our library file object file name my functions .o. Correct. Now even let us see. We will write this dash m32. Now let us check. One can see here this .so is created and this is our dynamic library. If I try to check this with file, you can see the name itself is added. It is a shared object, LSB shared object. Now, as we said like earlier with the archive library or static library, we added a lib prefix. Here also I'm adding lib prefix so that we can link it by directly writing my functions as a name. Okay. Now we will what we'll do is we'll write a program that uses our shared library functions. Fine. So let us write Emacs test lib.c. Now the library file, the header file name that we gave. Let us see what the file name is. Our file name is myfunctions.h. So we have to make use of this here. Okay. So let us write hash include std.h hash include then our library file name. So double quote it is to be used. So whenever we are having a user defined say file names or header files rather, always use double quotes. Fine. Now let us write int main and we'll give call to the function. So let us say we will call first the function. So let us see the names of the function again so that we can use them. So print message. So let me call that print underscore msg. Okay. Then let me write a variable here, integer result, which stores addition. So result add equal to our function name. So our function name for addition is add. So let us add another variable. Let us add another variable. So result sub equal to subtract 10 comma 20. So let us print the values. Printf addition is %d. So result add. Fine. So let us say let us copy this. Subtraction is %. Fine. And let us set return 0. So if there are errors, we'll try to correct them. Okay. Now here, what we did here, we included the header file. whatever the header file name that we gave. Correct. Now, while creating header file, you may be recalling like what exactly I did there for that header file. I actually used the header guards if definition, if and def, and has defined to prevent multiple inclusions. Okay, and we actually declared this as a header file. Fine. So let us save this code. Let us go out and let us try to link this together. Now we have to link our library to. Correct. Now our library name that we gave was libmyfunction. So we'll remove that lib prefix and then we'll use rest. So let us write gcc -m32. Say our program name. So our program name is what? testlib.c. Okay. Then as we used earlier .l dash l dot to communicate that current directory for the library should be checked. Fine. And the library name dash l. Now we know that we have to remove that lib and rest of the thing is to be added. My function. Okay. Dot so. So we don't write this so now because we have already written dash l. Correct. Let us see. Now we actually could get the executable. Fine. And let us execute this code. Now you will see like it is giving us error like saying that it cannot open the shared libraries. Now what could be the problem? Let us try to resolve this. So the error that it is giving to us is error while loading shared libraries. libmyfunctions.so cannot open the shared object file. No such file or directory. But if you currently see that file is available there. So we'll try to correct this particular error now. Okay. Now what we saw here, like while we are running the code ./a.out, we got an error, correct? Saying that cannot open the shared object file, and this is an error given to us. Now this is because Ubuntu or our OS doesn't know where your .so file is at runtime, despite we added it here, correct? It only is used to create a executable. Now what we have to do is we have to fix this shared library lookup. Now there can be different methods. So let us first write this. Okay. So what we'll do is we will export. Let me export. Okay. Then we write ld library library and path. And we want to set it equal to with dot. Fine. Now let us execute our ./a.out. Now you can see our program got executed. Now you may be wondering why exactly we did this. So this is a temporary solution that we applied. Okay. Now let us say, let me delete that shared file. We will delete a.out first. Okay. This is a temporary solution that I gave. Now this is useful in some places rather, but every time it is not the good solution. So we will see like why it is a temporary solution. So the variable that we used here, like this one, LD library path, this is an environment variable that tells the dynamic linker, direct or LD linker, where to look for shared libraries at runtime. Now this would be in addition to standard locations given, like for example, if we see on root, there is a lib directory, and with USR, there is a lib directory. So when we try to add this, like when we exactly did this, ultimately, we are communicating to the linker that please check the current directory for the library too. Correct? What is the library that we created? Please check the current working directory when running this program. But now, as I stated, that this is a temporary solution because it is session specific. Now, once we close the terminal and reboot the system, or maybe whatever way, like either you close or either you reboot, the environment variable is gone. So you will have to re-export every time whenever we want to execute such kind of function. And again, it is going to be very, very specific to the user because it only applies to the terminal or a user session where it is set. Other users, maybe scripts, won't inherit this setting automatically. And it is not suitable whenever you want to create a production environment. Like if you are having servers, cron jobs or system daemons, it is very difficult and it is said to be unreliable or non-standard procedure. So let us try to see now what is the long-term or production solution. So what we will do is we will try to copy our library into local library. Like for long-term usage, for production or for system-wide deployment, we'll do this. Okay. Now say, let us say, let me close this terminal for a while. Okay. Let me open another terminal again and let me execute the code. Correct. Now, if you see, like earlier when we executed, we removed it. Okay, let me create it first again. Let me execute this. Okay. Now again, what we'll do this one, we will not remove it. We will export it. Okay. And let us execute it one more time. The code executed. Now let me close the terminal. Let me open the terminal again and let me execute. Dot slash. Again, it give a problem. That's the reason why I said this is a temporary solution. Now to have it as a long-term solution, let us do this. So what we have to do is write sudo. Then your library name is write that library name. So your library name, let us check our library name. It is libmyfunction.so. So sudo cp lib my, sorry, it is capital My functions.so. Now you have to copy this into usr slash local slash lib. Fine. And then like you would input your user root password because we wrote sudo. Then sudo ldconfig. Now ldconfig, like initially what we did, we actually made this library accessible globally. Okay, then we are writing now ldconfig. ldconfig will update the system shared library cache. Fine. So it doesn't require now that ld library path. Fine. Now let us try to again execute the code. Now you must have seen our code got executed earlier, which was giving us error. Now it got executed. Now let us say, suppose if I am in the other working directory. So we will copy this code, cp myfunctions.c to p.c. Okay. And we'll move this p.c to dot slash. Okay. So we'll write here slash home slash Nitin. Let us remove it here. Okay. Now if we see our p.c is copied there. Correct? Let us compile this code again with the GCC prompt that we had. So the way that we created this GCC, we'll write the same thing here, but instead of that lib code, we have to write here p.c. Fine. Now let us see. We will try to find out what exactly this error is. Let us check p.c. Oh, so we took this code. So actually we should have taken the other code, like with the test library. So let us go cd. Okay, we will copy that code. Cp shared library, my shared library. Okay, and program names are like testlib. We want testlib.c to be copied as p.c here. Okay, now let us check p.c. Now it is containing this. Fine. Now let us link it again. Now you will see again, like the header file is not found. Correct? Because it may be probably there rather. What are the way where exactly it was added? It is not in the current working directory. Correct? So this is the case where now you have to really talk about, you have to copy this header file too to resolve the problems. Fine. So let us see now how to do this. Now, as we got this error, now the reason behind is like our library, the header file is not added here. So if I copy that header file here, okay. So let us copy header file because we used double quotes. Fine. So my shared library, then our header file name, my functions dot h here. Let us now you may see code got executed. Now you are not to do anything. Right. And this is how rather you can make use of the shared library. This shared library will be available. Only thing like as we created a header file, you have to copy that header file there. And thank you.